In this video, I'm gonna talk about electronic analytical balance. So on the left side, as you can see, that is the example of electronic analytical balance that we use to weigh in the meats. So there is two types of weighing. The first one is rough weighings. 2 or 3 significant figures are normally used. For the second types of weighing is accurate weighings, are reserved for obtaining the weight of sample to be analyzed, must generally be known to 4 significant figures, capacity to weigh 100 to 100 gram, measure to nearer 0.01 to 0.001 gram. So we move on to the next slide, which is safety procedures and weight techniques. For safety procedure, do not use balance at dangerous places like dusty room, near gas supply or near flammable fluid or solvent. The balance should not be placed where there is direct sunlight. Handle with care, never drop the analytical balance. The balance should not be placed near an open window or directly in front of the air-conditioned air vent. This will cause draft. Lastly, do not dismantle the analytical balance. For weight techniques, the first one is direct weighing. With nothing on the pen, set to 0 by pressing the button on. Place weighing bottle, beaker or vial on balance and set into container slowly until you reach the desired mass. For the second technique is indirect weighing by difference. Place enough of the sample in weighing bottle, put the lid on and place on the scale. Record the mass. Best to transfer small amounts at a time. If you guys wonder how to use this electronic analytical balance, so for the first step is, before you use it, it should be warmed up for at least half an hour. Turn on. Use clean paper pads to prevent the uptake of moisture by dry objects. Center the substance to be weighed on the pan. Weigh at room temperature. Never place chemicals directly on the pan, but weigh them in a vessel. Always brush spilled chemicals off immediately with a soft brush. Always close the balance door before making the weighing. Air currents will cause the balance to be unsteady. So there is sources of error too. The first one is not close the balance case door will cause high or low mass reading due to air current. Change in ambient temperature or temperature of the source of object being weighed is probably the biggest error. Hot or cold object must be brought to ambient temperature before being weighed. Hygroscopic samples may pick up moisture, particularly high humidity, atmosphere, and exposure to air prior to air and during weighing must minimize.
Next, we will look at the glassware. Laboratory glassware refers to a variety of equipment used in scientific work and traditionally made of glass. Glass can be blown, bent, cut, molded and formed into many sizes and shapes and is therefore common in chemistry, biology and analytical laboratories. The history of glassware dates to the Phoenicians who fused obsidian together in campfires, making the first glassware. Glassware evolved as other ancient civilizations, including the Syrians, Egyptians, and Romans, refined the art of glassmaking. Mary the Jews, an alchemist in Alexandria during the 1st century AD, is credited for the creation of some of the first glassware for chemical, such as the keratosis, which was used for the collection of fumes from a heated materials. Despite these creations, glassware for chemical uses was still limited during this time because of the low thermal stability necessary for experimentation and therefore was primarily made using copper and ceramic materials. Glassware was divided into two, which is non-volumetric glassware and volumetric glassware. But today, I will explain one glassware from non-volumetric glassware and one from volumetric glassware. Beaker is one of the non-volumetric glassware. Beaker is generally a cylindrical container with a flat bottom. Beaker have a small spout or break to make it easy to contain substances. Finally, beaker is used to stir, mix and heat liquids in laboratories. Next is volumetric glassware. One of the volumetric glassware is pipette. Pipette is used to transfer a particular volume of the solution. It's often used to deliver an accurately known volumes from one container to another. Pipette have two types of common, which is volumetric for transfer pipette and measuring or graduated pipette. Before we go to volumetric or transfer pipette and measuring or graduated pipette, we will go and look at other types of pipettes first. Other types of pipettes are Hamilton microliter syringe. Syringe pipette precisely deliver microliter volumes, commonly used to introduce samples into a gas chromatography. Next is single channel, multi-channel digital displacement pipette and microwell plates. This syringe pipette can reproducible deliver a selected volume. They come in fixed and variable volumes and the plastic tips are disposable. Now it's time to go at volumetric of transfer pipettes and measuring of graduated pipettes. Volumetric or transfer pipettes is a bomb-shaped pipette. It is pipette that delivers one single fixed volume. It is used for accurate measurements since it is designed to deliver only one volume. Lastly, it is available in size of 100 to 0.5 ml or less. Next is measuring of graduated pipettes. Measuring of graduated pipettes are straight bore pipettes that are marked at different volume intervals, TC. It can be used for accurate measurements, especially for small volume if they are calibrated at the volume wanted. This pipette less accurate than bound pipette due to non-uniformity of the interval diameter of the device. The measuring pipettes range from a total volume of 25 to 0.
Okay, now let's move to a heating apparatus. Today, I will explain about two apparatus, which is a Bunsen burner and a hot plate. What is a Bunsen burner? The Bunsen burner is a device for combining a flammable gas which controls amount of air before each ignition. It produces a hotter flame that will be possible using ambient air and a gas alone. It consists of a metal tube on a base with a gas inlet at the lower end of the tube. The Bunsen burner function. The primary function of a Bunsen burner is to produce a controlled flame for various scientific purposes. It utilizes a mixture of the gas and oxygen, allowing for precise regulation of the flame size and heat. The controlled environment ensures safety and efficiency during experiment. The second apparatus is a hot plate. A hot plate is a portable self-contained tabletop small appliance cooktop that features one or more electric heating element or gas burner. A hot plate can be used as a stand-alone appliance, but it is often used as a substitute for one of the burner from an oven range or a kitchen stove. Lastly is a function of a hot plate. In laboratory setting, of a hot plate is generally used to heat glassware or its content. Some of a hot plate also contain a magnetic stirrer, allowing the heated liquid to be stirred automatically. A hot plate produces heat by using electricity instead of a traditional means of producing heat by using a fire.
Okay, next, let's move to filtration apparatus and technique. There's two types of filtration. The first one is gravity filtration and the second one is vacuum filtration. But today, I'm going to talk about gravity filtration. Filtration is a technique used either to remove impurity from a solution or to isolate any solid. The impurity can be a drying agent or an desired side product or leftover reactant. Gravity filtration used in chemical laboratories to filter precipitate from precipitation reactions as well as drying agent in admissible side item or remaining reactant. Gravity filtration is an easy way to remove solid impurity or the precipitation from an organic liquid. The impurity is trapped in the filter. Gravity filtration can collect any insolid solid. This is filtration apparatus. First, we need filter paper, conical funnel, and beaker. This is how we fill the filter paper. Filtration technique. For preparation, make the clean container and wet the filter paper. For decantation, process of pouring a liquid gently and not disturb a solid in the bottom of the container. We need to use rod to stirring to avoid splashing during decanter. Washing. Several washing with small volume of liquid in beaker solution to remove solute contaminant. And the last one, transfer of the precipitate. The removal of the last trace of precipitate. Remove the filter paper and precipitate.